So in this video, I want to actually look at how to balance chemical equations. So how do you balance chemical equations? So this is what we are going to focus on. Let's start by looking at an equation that says, hydrogen reacting with oxygen to produce H2O. You can pause the video and try to, to balance it. But of course, as you balance it up, you need to look at the left-hand side as well as the right-hand side, the number of atoms. So if I look at the left-hand side and the other side, I'm going to say the right-hand side. So you look at the atoms that you have. In this case, the atoms that I have atoms of hydrogen and oxygen. Even on the reactant side, you should have the same types of atoms, so hydrogen and oxygen. So how many atoms of hydrogen do I have? You can see that there's a 2. But remember, in each case when you're dealing with this, there's always the number in front here, coefficient. So if you don't see any coefficient there, it simply means that there's actually a 1 that is actually in front of the molecule that you have. So there's actually a 1 that is actually available this side. But of course, we are not actually just showing it. We don't write it in the formula. So it's 1 times 2, which actually gives you, in this case, a 2. Then how many atoms of oxygen? Remember, again, there's a 1 there. There's actually a 1 in front there. So 1 times 2, that actually gives you just a 2. But we don't write that one. Remember, so you should consider it as being like an imaginary number. What about this side again? It simply means that there's a 1 there. That's the coefficient, the number that is in front. So this number multiplies by the number at the bottom. And the number at the bottom is simply called the subscript. So that is what you need to remember. So if I've got H2, the number in front is what we are calling as being the coefficient, of course. And the number at the bottom is simply called as being the subscript. It's simply called as being the subscript. So the coefficient multiplies by the subscript for you to know the number of atoms that are available in that particular atom, or how many atoms of that type that you are going to have. But in this case, I'm actually just trying to, to focus so that I can actually help you. So remember that 1 is imaginary. So it's like 1 times 2 will still give you a 2. And 1 times here, there's actually a 1, so that will give us, there's only one atom of oxygen. So now go ahead, if you try to look at this, try to compare the number of atoms on the left-hand side and the number of atoms on the right-hand side. You are going to find that for hydrogen, it is actually balanced, but if you look at oxygen, it is actually not balanced. So what do we need to do? We need to balance by having, the same number of atoms on the left-hand side as well as on the right-hand side. Then the equation is going to be balanced. So now when we balance, we simply add, whole numbers in front of, in front of the molecule that you have there. So you cannot change the subscripts. The subscripts do not change, but you only add coefficients in front of, the molecule that you have. So what number should I add so that I can have oxygen to be 2? It simply means that you can simply add a 2. Now, the moment you add a 2, it will become 2 times 1, which is now going to give you a 2 there. So you are going to have 2 oxygen atoms because there's a 1, remember, at the bottom there. So 2 times 1, you are now going to have 2 oxygen atoms. But the moment you add this coefficient 2, it simply means that you have affected the hydrogen. Now it will be 2 times 2, which is now going to give you 4. So you are now going to have 4 atoms of hydrogen on the right-hand side. Now notice the number of atoms of oxygen on the right-hand side and on the left-hand side is actually the same. But the number of atoms for hydrogen, because of that 2, it has now gone to 4. So what number should you put in front so that it can give you 4? Remember, you have a subscript here. So what number should you put in front when you multiply by this 2? It is going to give you 4. So it is actually a 2. So 2 times 2 will now give you a 4. So if you look at this one, the number of atoms on the left-hand side is equal to the number of atoms on the right-hand side. So we simply say the equation is actually balanced. So you just needed to add 2 there, and you needed to add 2 there. Well, let's try to do another one. Since you know about the subscript and also the coefficient. Let's try to do the second one. In this case, the second one that I have, let's say nitrogen is reacting with hydrogen to produce what we call as being ammonia. This is actually called the Haber process. Later on, you are going to look at the Haber process. It's actually a reversible reaction. So let's look at what we have on the left-hand side, and we look at the number of atoms on the right-hand side. So in this case, the number of atoms, I've got nitrogen, I also have hydrogen. It simply means I also have nitrogen and hydrogen the other side. So how many atoms of nitrogen do you have? It is only 2. What about hydrogen? It is only 2. What about on the right hand side? Remember, there's only 1. What about hydrogen? You are right, it is actually 3. Please, you can actually pause the video and try to see if you are able to, to actually work out this one. But let's of course see, how we can actually try to balance up that one. Now, for me to balance up that one, what I'm actually going to do is that I can add a number there, a coefficient in front there. I can simply, if you notice, there are how many atoms of nitrogen on the left hand side? There are 2. So to make it to make the right hand side of 2, I can simply add a number, a coefficient of 2 in front. Now when you add 2, it simply means, remember there's a 1 at the bottom, so 2 times 1, it simply means that it will now go, you have 2 nitrogen atoms. But when you add this coefficient, it simply means that the number of hydrogen atoms become affected. So it will be 2 multiplied by 3, which will now give you 6. So it will go now to 6. So you come back now so that you balance up. Remember, on the right hand side and on the left hand side, the number of nitrogen atoms have actually balanced. So our focus now should be on the hydrogen atoms. Since on the right hand side you have 6, so you need to ask yourself, what number should I put in front of this nitrogen so that it can give me a 6? Remember, when you put that coefficient times this one, it should give you a 6. Of course, it is actually 3, because 3 times 2, it simply means that this one will simply go to 6. I hope we are together. So that's the way you can do it. So you can see the number of atoms on the left hand side equals to the number of atoms on the right hand side. So it simply means the equation is actually balanced. All right, let's try to put up another one and see if you are actually able to balance up that. I'm going to give you magnesium reacting with nitrogen to form up what we call as being magnesium nitride. So this is the reaction that you're having, and they tell you balance up this equation. Please, you can pause the video and try to see if you are able to balance up this one. All right, let's continue. So we have on the left hand side, then we also have on the right hand side. So let's look at the number of atoms that we have. We do have magnesium and nitrogen. Even on the right hand side, I should have the same atoms, magnesium and nitrogen. But let's try to identify the number of each atom. Let's start on the left hand side. I've got on the left hand side, magnesium is only 1, nitrogen is actually 2. For magnesium, on the right hand side, there are 3 atoms of magnesium, and there are 2 atoms of nitrogen. So you can see that the equation is actually not balanced. So we want to actually balance it up. So now, how do we actually try to balance it up? Of course, where do we need in this case to start? Well, if I look at the number of nitrogen atoms on the right hand side and on the left hand side, it is actually balanced.